At this point, you know what a chemical reaction is, you know how to balance chemical reaction, you know how to identify the different types of chemical reactions. What we need to do is take it one step further and say, if I give you reactants and say, what are they going to make if they do react, you can tell me the products, you can predict the products. Now, our most important tools for this are going to be the ones that we already have. Reaction types and, believe it or not, nomenclature. Now, we haven't maybe done enough nomenclature to do everything, but we've done a good selection at this point, and we're only going to add to it, and nothing is going to change the fact that nomenclature is going to be a really important tool for this. Okay, so quickly reviewing the reaction types: the synthesis reaction, the decomposition reactions, single displacement, double displacement, and combustion. And you really should know these patterns by now, but if you don't, and even if you do, maybe jot down those things, and the patterns are more important than the names. Okay, when we're predicting products, like I said, the first thing we're going to need to do is identify what the reaction type is likely going to be. And that is sort of looking at the pattern of the reactants, what the possibilities are for the products. Obviously, you don't have the whole thing because the half is your job, but if you look at the reactants, what pattern would they likely to form? Then think about the pattern of the products, and then also think about nomenclature. Okay, let's start with this one. So if I have aluminum and oxygen combining together to make a compound, I really only have one option there for the reaction type, synthesis. They're just going to combine. Okay, so now I need to be thinking about what the pattern is, they combine, and then nomenclature. If oxygen and aluminum form a compound with each other, what is it going to be? Well, I know that aluminum is always +3 in compounds, and I know that oxygen is always -2 with metals. So when I put them together, I'm going to follow that pattern as well, the nomenclature pattern. Now, I don't have to balance these things normally in a predicting the products question, but it's not a terrible idea to do that. Get some more practice with balancing equations. If I move on to another one, mercury oxide, we haven't done the nomenclature of this, so I'm not going to be too worried about the actual name for it, but the only real option I have for a reaction type is decomposition. In a decomposition reaction, these two are going to go back to their elements. It's not always the case in decomposition, but it is definitely the case in this one. How do we know? It kind of depends a little bit on what you've got to work with. Not a lot to work with here. Okay, so now when they exist as their elements, what are they going to be existing as? Well, mercury is fine because it's a metal and it's just going to exist as single atoms, but oxygen, nomenclature, is a diatomic element. So when I write out the products, I have to take into account what I already know about their nomenclature, which is diatomic oxygen. Again, I don't have to balance these things, but it's not a terrible idea to do so. However, if you're just writing down what I've written down, doesn't count as balancing it because I did the work. If I carry on to this one, I've got a metal with a metal-nonmetal compound. Single displacement is my likely pattern. Now in this case, the metals are going to trade places so that magnesium goes with chlorine and iron lives on its own. Okay, so when magnesium and chlorine are going to form a compound together, that's a metal-nonmetal compound. What do I know about that? Nomenclature. I don't have to name it, but I have to understand how the pattern for the nomenclature works. So chlorine is always -1 with metals, magnesium is +2 in compounds, so I'm going to get that. Now again, if you're thinking, wait a second, I had 3 chlorines on one side, now I only have 2, but I haven't balanced it yet, so I can take care of those problems in the balancing. The most important part is getting the formulas of the products correct, because that's more important than the balancing. Think about when you were balancing reactions, you were always given the formulas. You just took them as they were, and then you made them balance. We're doing the same kind of thing, except you're coming up with those final formulas. Double displacement reaction. One of the last ones I've got left, so I was running out of options anyway, but again, I've got a metal-nonmetal compound with a metal-nonmetal compound. Not a lot of other options. So, double displacement reaction, think about the pattern. Those two metals are going to trade places. So now I'm going to put sodium with chlorine. What's the formula for that? And I'm going to put gallium with sulfur. What are the formulas there? Now, one thing about double displacement reactions that should be mentioned, and I have it up here, is that the charges do not change. Here wouldn't matter because sodium is always +1, gallium is always +3. But in other ones, we're going to have to remember that the charges do not change. Anyway, carrying on. Sulfur, -2 with metals, chlorine, -1 with metals. Okay, so when I put them together with their new partners, they're going to form different ratios of atoms. That's okay because A, that's what the ratio is, so total positive charge equals total negative charge, nomenclature. But also, I haven't balanced it yet. If I do balance it, then all the numbers are going to work out just fine. Make sure that it really gets in our heads that the nomenclature is the important part. The pattern of how these things form compounds is the important part. The other numbers, they're going to work out in the balancing. Combustion. Now combustion gets a little bit weird because it's not always going to be just carbon-hydrogen compounds reacting with oxygen. It can be other things. We had an aluminum a while ago that could have been thought of as a combustion. But the one thing to keep in mind with a combustion reaction is I'm going to get the common oxides. Now, what in the world does that even mean? There are certain elements that when they form compounds with oxygen, they typically do this. So for example, with carbons, typically carbon dioxide. With hydrogens, typically water. There's a few other ones that we're not going to worry about too much, and if we need to worry about them later, A, it's not going to be on a predicted products, and B, I'll give you some help at the time. Anyway, so combustion, if I can recognize the reaction type, should be one of the easiest things in the world because those are the products, always, every time. Still haven't balanced it, and you can if you want. It's not going to be our biggest priority. Okay, a couple things to keep in mind. Number one, nomenclature. I'll probably write that down later, but the reaction that you give me as predicting the products does not have to necessarily be right all the time, but it needs to make some sense. Okay, it's hard to give you an example of that, but well, I'll have this one. If I asked you to come up with that one, the temptation to say, okay, it breaks down into its elements, pretty strong temptation. It would also be incorrect. The actual answer is this. Well, how are we supposed to know that? That's my point. You're not. So what you were to get, if I said, hey, give me the products for this one, and you came up with something that was at least reasonable based on what you know at this point, that's okay. Might not be right, but it's okay. Predict the products. Hey, we can check later. Right? I've got a hypothesis. I'm only going to really give you ones that I can reasonably expect you to know. So for example, a moment ago we were talking about some of the nomenclature that we have not done yet. All right, well I can't really do much with those, can I? So, in time, and then normally I don't ask them to be balanced. If balancing helps you make sense that things are working out the way they should, perfect, go ahead and balance them. Otherwise, don't worry about it. And again, nomenclature. And really what's all we've done today is that. We probably did a little bit more nomenclature review than you realized, but really our big thing was that. Talk to you another time.